Hey guys, welcome back. We're looking at 1.3 today, Scott's Macho March. Let's go ahead and jump right in. All right, so what we are looking at here is multiplying two binomials. We've looked at the distributive property on two different terms in the same problem, multiply and simplify as such. You may have noticed the binomial 4x plus 1 occurred twice in the problem. Here's a simpler way to write the same problem. 3x plus 2, quantity 3x plus 2 times the quantity 4x plus 1. You will use the distributive property twice. First, multiply 3x times the quantity 4x plus 1, then multiply positive 2 times the quantity 4x plus 1. Add like terms, write the x squared term first, and the x term second, and the constant term last. So this is giving you an example of how you can take and go about doing this using the distributive property twice. I am also going to show you guys, I'm going to show you guys how to use FOIL, first, outer, inner, last. In my opinion, it is an easy way to take and work through these problems. Most people find FOIL easier to work with than doing the distributive property twice. Not everyone, but it works essentially the same way. You get the same answer in the end, no matter what. All right, so we are looking at number 1. So let me make the screen big. Okay, so FOIL, like I said, first term, outer, inner, inner, and last. So what it means by first, that means we're taking the very first term of each of the two parentheses and we're multiplying them together. So x times x is x squared. Then it says outer, so we're going to take the two outermost ones, so x and negative 7, so we multiply those together. So we end up with a negative 7x. Then we do the inner, so the two that are right next to each other, but in opposite sets of parentheses. So we have 5x. And then we do the last, so the last two terms of each of the parentheses. So 5 times negative 7 is negative 35. Now, we combine like terms. We have two terms that both have an x. So the x squared stays. Negative 7 plus 5 is going to give us a negative 2x minus 35. That's our answer. This is using FOIL to take and multiply the two binomials together. Now, like I said, you can use the distributive property. That just means you're taking the x times the x and the negative 7 and the 5 times the x and the negative 7 and then combining terms. So it works out the same in the end. So I'll go ahead and show you that as well, just so you know it. Let's see, x plus 5, x minus 7. So we're going to have x times x minus 7 plus 5 times x minus 7. So x times x is x squared. X times negative 7 is negative 7x. 5 times x is 5x. 5 times negative 7 is 35. You're probably noticing how this is very, very similar to what we just did in FOIL, but without having to rewrite it as x times x minus 7 plus 5 times x minus 7. Combine our like terms. So x squared minus 2x minus 35. So exact same answer both ways. But FOIL is definitely helpful when we're taking and doing these, and it makes it a lot easier than having to write it out. It's just all about knowing those. First, outer, inner, last. Okay? All right, so that's what you're going to do for 1 through 9. Then for 10 through 15, you're going to be taking and looking at some sequences. So, whoops, let me shrink that back down. Okay, so distinguish between linear and quadratic patterns. So we're going to be dealing a lot with some patterns in here. Pattern is your keyword for this lesson. Pattern is your keyword. So we're going to use the first and second differences to identify the pattern in the tables as linear, quadratic, or neither. Write the recursive equation for the patterns that are linear or quadratic. Okay, so we are going to look at number 10. So for number 10, we're going to be taking and looking at our y values to see, are we going up by the same amount every time by adding or subtracting, or is it using multiplication? So we're looking at our first differences. So from 23 to, from negative 23 to negative 17, how much did we go up? We went up 6. From negative 17 to negative 11, we went up 6. From negative 11 to negative 5, once again, we added 6. From negative 5 to 1, we added 6. From 1 to 7, we added 6. From 7 to 13, we also added 6. So our pattern is, it's a linear pattern because our first differences are all the same. Now, if these would not have been all 6, then we would have looked at the difference between each of these. So we would have looked between the first and the second ones of the initial differences. So like between the 6 and 6, the difference between those in this case is 0. In another situation, maybe it would have been 2, and then we would have gotten all 2s. That would have been quadratic. All right, so our recursive equation is going to be now equals previous plus 6. So this is what we're most used to seeing with our recursive equations. The other method for writing this recursive equation is f of n minus 1, which shows us n would be our current number that we're on, minus 1, which means the previous, and then plus 6. So either one of those two is perfectly acceptable for this, all right? Excellent. All right, so that's what you're doing for the next set. So it's either going to be linear, quadratic, or neither. So if the first differences are all the same, then it's linear, just like this. If its second differences are the same, it's quadratic. And if first and second differences aren't the same, then it's neither. Okay? All right, the last part that we are looking at is looking at writing the first 5 terms of the sequence. So a sequence typically has some sort of pattern. Remember, that is your keyword for this lesson. So this tells us that f of 0 equals negative 5. F of n equals f of n minus 1 plus 8. So 0 represents, that is our starting number. So this is the first term. Then we're going to go and we're going to add 8. So negative 5 plus 8 is going to give us 3. 3 plus 8 is going to give us 11. 11 plus 8 is going to give us 19. And 19 plus 8 is going to give us 27. So that is how we find the first 5 terms in the sequence. So you're given the f of 0 term, so that's the starting term for you, and then you just have to find the next 4 using what the recursive rule says. So in this case, notice it says plus 8. That's key. That's what you're doing each time. If this would have said minus 8, then we would have been subtracting. In some cases, you may see it wrote out as f of n equals 6 times f of n minus 1. You may see something like this. This means multiplication. That means you're going to take whatever the previous was. So like if it were this case, you'd take -5 times 6. That'd be your next term, and then you'd keep multiplying by 6. Okay, so this is what it looks like when you're going to multiply each time. This is what it looks like when you're adding or subtracting each time. Okay, so these are different kinds of sequences which have a pattern. Your keyword is pattern for this lesson. If you have any questions, feel free to ask. Hope you have a great day.